Hello there, I'm Thomas Lszh, German American pilot flying the Boeing 787-900 to 95 from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to Zurich International Airport, runway 14 for an Ilsloc localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure of the outside atmosphere, and the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climbing center of the aircraft in 10,000 feet per minute, all the signals of the chronometric angles in degrees. You can climb the descent, you can set from the autopilot flight director system panel. We have the altitude indicator with the flight mode down here, the autopilot, we have the flight mode down here with the autopilot and the autothrottle later and vertical navigation modes, and the altitude indicator with the artificial horizon, the pixel degrees, the background rolling degrees. Also the Lszh localizer, the horizontal localizer and the vertical glide slope. You can follow the radio frequency transmitted from the antennas of the runway threshold of the runways we use for takeoff and for landing. So we have the Lszh localizer indication in the primary flight display to guide us with the horizontal and vertical flight path for takeoffs and for landings. We have also the Lszh localizer crossbars. The flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the HSI, the horizontal situation indicator with the standby integrated flight plan display. You can see the flight plan here. We have the magnetic head. You can track the magnetic north pole and true north pole. The magnetic north pole and geographic north pole and magnetic variation everywhere around the world. We have the display in the navigation display. You can see the horizontal and the vertical profile of the flight plan here with the magenta line. You can see the terrain and weather reflections from the weather radar. You can see the red, green and yellow indications from the terrain around you using the terrain map. And the elevation of the terrain around you for warnings. So we have also the display of the sea with blue, sea lakes and other water like rivers. So we have also the airports, the waypoints, the work stations, the ADFs, the NTPs. So we have the airports displayed with the 4-letter account name. In the display we have the runways also of each airport we can use for takeoff and for landing, displayed with the orientation and the length. We have also the waypoints, which are horizontal and vertical navigation fixes the aircraft will have to transverse through as we fly. Those one we have selected already. So I've selected using the flight management computer over here. I created a flight plan or a flight path or a route. You can see I have the legs of the route over here of the flight plan. So you'll see the flight plan displayed here with this purple magenta line here. You have to we're gonna take off from this runway and then climb through, make a turn over here, then descend, approach the landing again, and we have to cross through this TRA CI-14 OSNEM, and we have many more waypoints we have to cross through. So you can see the waypoints, the intercept over here, Z8710, Zui, also Negria 1 Alpha and Amiki are displayed here in the flight management computer. You can see from takeoff. So I will explain in a couple of minutes all these things in the flight management computer and the flight plan. So we have the workstation, the ADFs, the NDBs. We have the navigation aids in the navigation display. You can see also the outside view, the flight controls. So we'll make a complete flight from takeoff, climb, cruise, and approach the landing. After I will show you and explain you all the systems of the aircraft and make an engine start demonstration. So stay until the end part of the video. So now I'm gonna show you, I'm gonna explain you. We have the navigation display. You can see the profile also. As I told you, the terrain, you can see here this brownish color, the terrain right now around you, and the vertical profile. You can see where the aircraft is situated right now, and when it's flying, how far above the ground it will be. And the terrain, you can avoid some mountains like this, the intercepts here. So you can see the flight plan here, this line again, the vertical profile. So you can compare the altitude we're gonna be flying. We're gonna change the target altitude in a couple of seconds, and you have both horizontal and vertical profile navigation display. Also the engines indication here, autopilot, flight director system panel, other systems, thrust levers, flaps and slots, speed brakes, horizontal trim stabilizer here, and here the yoke. We have the flight controls. I will start explaining in a couple of minutes. The FS panel, you can set the barometric pressure of the atmosphere to set the barometric altitude. We have also the overhead panel. I will show you in a couple of minutes also that. So I created a flight plan here using the flight management computer. I input the data of the aircraft for this flight. That includes the takeoff gross weight. That includes the empty weight plus the passenger plus the cargo plus the fuel on board. That includes the trip fuel, the reverse fuel, and taxi fuel. We have where the flight management computer is going to calculate where the fuel is stored in the left and the right wing, how much in the center tank also, and the loads of the cargo and passengers. So it will give us the center of gravity, the minimum aerodynamic chord of the aircraft position, and the center of gravity, and the horizontal trim stabilizer for takeoff. I'm going to use the flaps for 15 degrees. For this runway, we are situated in the runway 14 in the Zurich International Airport, the Lszh. Runway 14. So we have the flight management computer has stored the runway length, the runway slope, the wind direction and speed. Also we have maybe to insert, we have also the barometric pressure, the density of the air, the temperature is going to give us the takeoff speeds, also the runway conditions, if it is ice, dry or wet. On the takeoff speeds, V1, V rotate and V2. Also we have the V2 plus 15 knots after takeoff. So for using 15 degrees of flaps, it's going to calculate using the gross weight of the aircraft and the fuel on board, where the fuel and the loads, the cargo and the passenger are stored. You can calculate the center of gravity and the mean aerodynamic chord position, the Mach. The mean aerodynamic chord position is right now 33%. Is the position where the maximum aerodynamic lift occurs in the forward wings. Is the position where also this calculates the center of pressure, and also the stall. It will begin the top surface of the wings, the airflow will become detached in the top surface of the wings, and the aircraft will gonna start stalling in the air. So we need to avoid the stall speed all the time by monitoring the primary flight display, the airspeed indicator here. You can see where the stall speed is displayed with a yellow and red line. So our airspeed during the whole flight is gonna be more than the stall speed as much as is possible. So this is affected also by the angle of attack and the attitude of the aircraft in flight and the airspeed. So the thrust also provided by the engines. So I'm gonna show you that also. So we have the takeoff from this runway, the Zurich International Airport, Lszh runway 14. We have the 6 other instrument departure waypoints and fixes for the initial climb of the aircraft. We have the climb to the cruise level. The aircraft is gonna cruise over there. We're gonna use 25, 36, 37, 38, 39, 30,000 feet above the sea level. We're gonna cross through some waypoints. I'm gonna show you. We'll display Zui and Negri 1 Alpha and Amity for these levels. Then we're gonna start the descent We're gonna have the stars, the southern terminal arrival waypoints and fixes when we descend from like 28,000 feet back to 7,000, 6,000 above the sea level, back to the airport elevation, which is 1,430 feet above the sea level right now, barometric pressure altitude. So also that we have the stars, the southern terminal arrival waypoints and fixes that include the terminal, the long final and the short final. We have the terminal arrival waypoints and fixes that include horizontal, vertical navigation fixes and altitude and airspeed constraints for the approach and landing. We're gonna use these for alignment of the runway. I'm gonna use the magnetic north pole heading of the runway 14 of the Zurich International Airport, 136 degrees. So we have to align with this alignment magnetic heading, and also the Ilsloc localizer is gonna be the same. We're gonna have it tuned on this frequency for this runway, the Zurich International Airport runway 14, the Lszh 14. So we're gonna have the ILS localizer Zurich International Airport runway 14 displayed in the primary flight display. Will give us the horizontal localizer and vertical glide slope for guidance with the runway. For approach and landing, we're gonna have also like full flaps, 25 degrees or 30 degrees, and also we're gonna have a pitch attitude about 9 degrees or less in touchdown, also for takeoff. And we're gonna use like 145, 150 knots or higher, maybe 160 with airspeed with wind correction, because we have some side wind. We're gonna use higher speed for approach and landing and also for takeoff. So we're gonna have all these things. We have a complete flight plan or flight path route here in the flight management computer. I will show you now a little bit what I did with that. So we have a flight plan created here. As you can see, I insert all the data here, initialize. We have the index here, ident position. You can set the position. We have also ident position. We have the GPS reference over here. Index performance. I set over here 0 fuel weight plus fuel on board. So we have the 0 fuel weight, it's the empty weight of the aircraft plus the passenger plus the cargo. Fuel on board 35,800, gross weight 358,000 over here. Gross weight, the reserve fuel 5%. We have the cruise altitude 25,300. Cost index 100%. Fuel freezing temperature is minus 37 degrees. Cruise center of gravity 28%. So we have the route using origin and destination here, and the runway for takeoff, Lszh runway 14. Departures again, Lszh runway 14, trans Zui, and here we have Lszh arrival runway Lszh 14, trans Negria 1 Alpha, trans Amity. So we have the legs here created. From takeoff, active route 1. We can use also backup route if we need a second route. So we have the airspeed on the altitude we have to be crossing through its waypoint over here, and the direction over here. So the airspeed is going to be 324 knots. So the altitude is 6,000 feet above the sea level. So we continue here. We go through the cruise level, 35,300 feet, Mach 0.577, through Nigra and through Maldiv and through Amity. We start the descent to Zui, 7,000 feet, ZH. This is the stars, the southern terminal arrival waypoints and fixes. I forgot to mention these are the Cs, the southern instrument departure. So this is the standard instrument arrival after the cruise. Lszh final approach fixes. So we have runway 14 over here. final approach 140 knots and 1430 feet. So we have alternate also VNAV, progress FMC, fix, hold. Over here we can hold navigation radio. Initialize, we use the takeoff flaps 15 degrees, center of gravity trim for takeoff, so we're gonna trim the horizontal tail of the aircraft. And we have V1, we rotate, and V2 the takeoff speed for this gross weighting. So this is the stored flight management computer flight plan over here, or flight path. So I'm gonna show you now a bit the flight controls of the aircraft. I'm gonna show you the horizontal trim stabilizer. I'm gonna show you also the autopilot flight director system panel, the thrust levers over here. So you will see a lot of interesting things. So I will show you the thrust levers here. Also you can see I have this Lszh Extreme 3D, the size stick. So I will explain you how I use for climb descent. You can see the control, the yoke. I have the control column for climb and descent to move the elevator of the horizontal tail, make bang rolls right and bang rolls left, turning left and right. Also use the rudder pedals if I want, only for turning using the rudder, the vertical stabilizer. So we have the horizontal stabilizer over here, moving up and down the elevator. We have also the horizontal trim over here. I forgot to mention. We're gonna trim using the center of gravity in the mean aerodynamic core position the aircraft during the whole flight from takeoff, climb, cruise, descent, approach, and landing. The flight management computer is going to calculate the trim position. Use also the flight control computers, the autopilot flight director system panel, and auto throttle. And we're gonna have automatic trim from takeoff, climb to cruises and approach and landing. If we need, we can use the manual trim switch to trim the horizontal tail of the aircraft manually. Also the flight management computer, as we fly, the aircraft burns fuel, so it will shift the center of gravity during flight. This is also recalculated during flight. So we have here, as you can see, I will talk to you about Newton's physics, aeronautical and aerospace engineering, burn theory of fluids. And I'm gonna show you some equations and principles about flying. We need also for the air transport pilot license. So you can see the wings of the aircraft hold the aircraft weight as we fly. We have the thrust, the propulsion from the engines. We have the mean aerodynamic core position, 23% here. Is the position where maximum aerodynamic lift occurs in the wings, also where the stall will begin. So we need to avoid the stall in flight. The airflow will become detached from the top surface of the wings. We have the wingtip to wingtip here. The lateral axis, the longitudinal axis from nose to tail, the vertical axis through the center of gravity, and also where most of the fuel is stored in the left and the right wings under tangles. And we have the longitudinal axis also is used to calculate the horizontal over here trim, the horizontal stabilizer, horizontal tail as we call it. We have also the elevator for climb and descent, and the horizontal trim stabilizer trim position. We can trim it the whole surface, like trimming the whole plane up and down of the horizontal tail during flight. Also we can trim the rudder and the ailerons if we need. We have the ailerons and spoilers here for deflection. So we have here also, forgot to mention, we have the wings. You can see the bottom surface is more flat, and also we have the curvature from the flaps. So as we take off and then fly, we have using the Bernoulli theory of fluids, the airflow is moving slower below the wings. So we have higher pressure of air below the wings, which pressurizes the aircraft wings and weight up into the air. So we have also the top surface of the wings. We have more curvature in the top surface. So there is a higher airspeed of air above the wings. This creates lower air pressure above the wings, which sucks the aircraft weight and wings up into the air. So this is what we need to do. We have all this also from the tail over here, the vertical and the horizontal. So this is the main components. Principle is very simple. So we're gonna here. So I'm gonna show you now the flight controls of the aircraft. The yoke, we have the yoke of the Boeing 787-900. Have the side stick to control the yoke for this Microsoft Flight Simulator. So I have the same inputs in flight. From the side stick I can control the yoke to move up and down the horizontal tail of the aircraft, because the side stick deflection is proportional to the yoke. Also the ailerons and the spoilers. I can move all the flight controls together. We have also the tiller, which is interconnected with the rudder pedals for nose steering the ground. We have the toe brakes in the rudder pedals, and also the rudder pedals for the vertical tail. Over here the rudder, as you can see, you can move the rudder left and right like this. Also use the elevator, as I show you, the ailerons and the spoilers, the control wheel to make turns right and left like this. So we have also the thrust levers here, as you can see. I can move the thrust levers forward and move the flight controls together. So we have also the flaps and slots, the speed brakes, the horizontal trim stabilizer, I'll mention now. So you can see the engine indications here. Change the left and the right engine as we apply more thrust. So we have the idle thrust now. I can show you, maybe have a better view like this. So we have here side 6 can move the horizontal tail up and down in flight. For climb and descent, bunkers left and bunkers right. Also the rudder pedals. So climb, descent, make turns to the left and turns to the right. Also the rudder pedals. So I hope you like it. The size of deflection is proportional to the yoke deflection, as you can see. The thrust levers also. And the horizontal trim stabilizer. Horizontal trim stabilizer. You can see the captain and the first officer are interconnected and move together in flight, unless we have some failure, not like in the Airbus we have the side stick priority. Also you can see again the outside view one more time. We can climb and descend, make turns left, turns right, bunk rolls. So use the tail like this, climb, descend. So we have now I believe this is enough for the flight controls lesson right now. So now I will show you the rest of the systems. I will show you the horizontal trim stabilizer right now. The horizontal trim stabilizer, and then the rest of the system. So the autopilot flight director system, balance, thrust levers, overhead panel. So we have the horizontal trim stabilizer here. We can trim the horizontal tail of the aircraft like this. Trim up this way is trimming up, and this way is trimming down. So you can trim up or trim down the tail of the aircraft. So you have a nose up or nose down pitch trim. 4.5 right now. 4.25 is requested, so we can change that. If we input a little bit more pressure, we will change. Over here we have the alternate pitch trim. So you can see here we move the horizontal tail of the aircraft up and down in flight for balance in the aircraft. So we have the alternate pitch string. This way it speeds up and this way it speeds down, so you have to pay attention to that. We have also the parking brakes here. Besides that, we have the horizontal trim stabilizer cutout switch. So this is the normal switch, manual all the time, trim up and trim down like this. The horizontal tail of the aircraft, you will see the horizontal tail moving up and down like this displayed here. We have the flaps, also the rudder trim, a bit more information. So we have the horizontal trim stabilizer cutout switch here. This red guarded switch, you open from normal to cutout for Boeing 737, 747, 757, 767, 777 aircraft. 787, you have failure L2R2 hydraulic system for the Boeing 787. The autopilot flight director system panel, the auto trim function will be malfunction, so you open the guarded switch here and disconnect from normal to cut off. Then you can use, I believe, the alternate pitch string, and also you use all the time the manual pitch string here. You always have manual pitch string like this. So I'll show you a little bit more the systems here. You can see here we have the indications, the primary flight display. I will change the indication from the autopilot flight director system panel, the navigation display, the flight plan, the engines indications of the autopilot flight director system panel. Here you can see you can set minimums, radio, barrel, barometric setting, inches of mercury, hectopascals, and the range and the plan settings here. So we have the autopilot here. You can see autopilot engage and disengage switch here. You pull down this, you disengage the autopilot. We have the auto throttle like this, engage and disengage switch. We have the LNAV and the VNAV like this. You will see take us off like this and turn off. We turn off the flight director. This disarms all the flight modes and also the flight director. We cannot reconnect the autopilot right now, so we need the flight director on. We have the airspeed guidance, indicated airspeed, we cannot change that. Climb continuous, auto throttle, lateral navigation and vertical navigation, flight level change if we need to change the altitude using an airspeed mode. So this takes information from the flight management computer for the LNAV and the VNAV, the lateral and vertical navigation. We have the airspeed, we're gonna fix it for after the takeoff like this. We can have knots or Mach. We have the bank angle in flight, so this is the heading guidance. Magnetic north pole heading, we're gonna say 136 degrees. Same like the runway of the Lszh airport, Zurich International Airport, runway 14. So we're gonna have 136 degrees for that. We have also the altitude here, the altitude setting, vertical speed also. So the altitude, I'm gonna set thousands, 35,000, 100, 200, 300. VOR localizer, approach, VOR localizer, hold vertical speed over here. Flight director again on vertical speed, so you can descend like this, minus 2000. So we have the zeros, plus 300, 1500, 2000, 3500 like this. So this is the vertical rate of climb descent. Now we have vertical climb. We have also the descent display. If we need to descend, all the information will be displayed in the head-up display and the primary flight display. As you can see, whatever we change, all the indications will be available here. For the primary flight display, you can see the airspeed indicated, airspeed selected from the autopilot flight director system panel, same airspeed, same vertical rate of climb and descent, same altitude here, and same heading. So you have all the guidance mode of the autopilot flight director system panel. Target altitude 25,300, our current altitude elevation 1,430 feet. Primary flight display, flight director here. You can see the pitch ladder in degrees, 2.5, 5, 7.5, 10 degrees, 12.5, 15, 7.5, 2 degrees. Pitch up or pitch down. So you have to pay attention in the air when you fly. You don't know really if the aircraft is pitching up, but it might be falling down. So you have to pay attention both the pitch attitude and the vertical rate of climb and descent, and also the airspeed. Radio altitude above the ground level. Also the bank angle here in degrees, how steep bank angles you make when turn in flight with roll. You can see the vertical rate when we climb and towards the target altitude. We have the first waypoint here, 1.6 nautical miles intercept. So you can see again the flight plan here, the vertical. As I told you, now we have different target altitude, 25,300 here, 1,900, 2,500 intercept, cruise altitude, then descent over here. If we change the range, you can see also the runway. We are located here in the GPS setting display. The runway, our aircraft location, the taxiway in front of us, and the runway 16. So this is the International Airport runways here, as you can see them from outside view perspective. This is what you see in the GPS information with the terrain also available. So you have some awareness of the terrain. We have also other aircraft that fly around us using the transporter, the ADSB and ADC transmitter receiver. So you can see the runway as I saw you, the taxiway, the terrain in front of you, the gray, yellow, green, and red, depending how far above you are from the ground. The LNAV also the indication. So this is all the navigation air data. So the air data, we have the air data computer. Computer in the overhead panel, so I will start turning the overhead panel in a couple of seconds. So this is the autopilot settings for the primary flight display. All the air data, airspeed, VC, altitude, barometric altitude, pitot, static, pitot dynamic, the airspeed of the aircraft, laser gyroscopes for laser gyroscope alignment, inertial reference system, IRS alignment with the magnetic North Pole and the geographic North Pole, depending on where we are in the world. The angle of attack of the aircraft as it flies. So the airspeed, altitude change using barometric, pitot static and pitot dynamic, the angle of attack, radio altitude. So this compares all the information. Also the GPS receivers, we have 3 GPS receivers over here in this section. This is the air data computer of the aircraft. So the air data navigation is supplied to all systems, also flight management computer, autopilot, flight director system panel, all the throttle. So we have the thrust levers. I will start showing the thrust levers, then we make an engine start demonstration. You can see also here we need to start the APU, the smaller turbine in the tail of the aircraft, to make an engine start demonstration. So here we have the displays. Here you can see the left and the right engine information. We have the idle right now 19.8%, takeoff 100.4% with green, yellow, and red. You can set the thrust levers forward or up. You will see the thrust levers, the thrust changing. You can see compare the target versus the actual. So it takes like 3-4 seconds for the engines to react all the way up or down. So you have to anticipate that in flight before the airspeed decreases, for instance. So you have the N1, which is the low speed starters, low pressure. The low pressure compressor turbine of the turbofan, which is sensing the exhaust gas temperature per engine 530 degrees Celsius. Some warnings here with amber parking set doors, so those are the other information you have here in the display. So N1, red yellow-green markings. Exhaust gas temperature into which is the high-speed status of the high-pressure compressor turbine of the turbofan, which is engine. The fuel flow parents per 1,000 kilograms, 1,000 pounds oil pressure, oil temperature, oil quantity, and the vibration of the N2 states of the engine. We have here also gross weight of the aircraft, saturated air temperature, fuel temperature, and total fuel on board, thousands of pounds. The display has also horizontal trim, stabilizer, rudder trim, and the flaps position. So we have the flaps here moving, which also sync on the reef flight controls. You will see how many degrees you can set the flaps here, move. So you see the display here. You can see also the flaps are extended fully here, left and right wing. We have also the speed brakes, retract and extend. Some more display here in the overhead panel, a few more things. We turn off the pressurization from auto to manual. It will display us in the ACAS display, the engine indication and crawler system display over here. We have the display here of the indications. Cabin altitude 1,400 feet, rate climb descent differential pressure is gonna be like 7.8 psi maximum, the cabin pressurization, and the altitude of the cabin is gonna reach 8,000 feet when we're gonna be flying at 40,000 feet. So at 40,000 feet also differential pressure 7.8 to 8 psi, landing altitude 1,430, and you can see the outflow valves closed and open position. So we have the engines, the thrust levers. You can see the thrust levers moving forward and aft. We have the auto throttle here. Disconnect switch here. We can disconnect the auto throttle like this, pressing this switch. We have the takeoff go round switch and the thrust reverse. You open up, pull up this handle. You will see the reverse engaged here, 33%. So you see the blocker doors open, and you can disarm the thrust reverse like this, moving forward from the idle position. Also this extends the speed brakes for landing. So we have this horizontal trim stabilizer, cutout switch, fuel flow control for the left and the right engine, fuel control switch. We'll turn off and turn on the engines later. Fuel, we have the fire extinguishers for the left and the right engine, pull out and switch, the transporter, the rudder trim. So this is radio communication panel, navigation and communication radios. We have the overhead panel. We'll start showing you all the systems. Right now we're gonna make an engine start demonstration. So we have the engines, the GNX engines installed on a Boeing 787-900 aircraft. One in the left wing, one in the right wing, full symmetrical thrust and redundancy. One contains a FADEX gearbox with a FADEX. The FADEX are the full fluid diesel electronic control computers. One installed per engine gearbox. Dual channel redundancy, one sound phase, the other takes over control. Small switch display all the engine data and functions in the upper and lower ACAS, so the multi-function display like the main one, which is low speed stars have low pressure compression and turbine of the turbofan, which engine the exhaust gas temperature per engine. Then to which is the high speed stars of the high pressure compression and turbine of the turbofan, which is engine the fuel flow parents per 1,000 kilograms, 1,000 pounds oil pressure, temperature, quantity, the vibration of the N2 stages of the engine. The pressure rates are 59 states from the status section. Pressurizer, which is used to relieve the pressure inside the engine. If we have overpressure, or to increase it, we have under pressure. Also to supply other systems with pressurizer from the engines, we need the hydraulic fluid tanks pressurization, wing and engine anti-ice, air conditioning, ventilation, oxygen regulation inside the cabin, and cabin pressurization as we climb descent. So when we move the flight controls like these, the thrust levers, thrust reverses, landing gear extend and retract, parking brakes, nose wheel steering, rudder, elevator, horizontal trim stabilizer. So all the flight controls used in the wings of the aircraft are moving using the hydraulics from the engines, compressors, and also pressurized air tanks. So we have also pressurizer from the bypasser section. We have So we have all these things. We have also the Farex control, the fuel metering unit, fuel flow to the engines, fuel engines start, engines shut down, engine failures. Also, we have the fuel heat exchange sensors. We have to heat the fuel on board the aircraft all the time when we fly to avoid fuel freezing. So it recirculates when we fly high altitudes to the engines to duct heat from the engine component to cool down the engines components, and also to heat up the fuel and also the oil of the engine. So we have the recirculation of the fuel and the oil and the sensors for the temperature controlled by the Farex. Also we have, as we fly the aircraft from the sea level all the way up to the cruise level, like 20, 30 or 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea. As we climb higher and higher, the pressure of the air, the oxygen level is becoming less than half of the sea level. Also the density of the air, also the temperature of the air becomes freezing, like -30, -40, -50, -60 degrees below zero. Also the aircraft is going to be flying with an airspeed rate about 2 or 3 times faster than that of the sea level. So we're going to have a higher intake of air from the front fans for compression and combustion into the engines. So we have a different fuel mixture request every second, which is adjusted automatically from the Farex, instead of doing manually like you do in the trainer propeller aircraft or turboprop aircraft. You have the automatic fuel mixer adjustment. You have also, as you descend from the cruise level back to the sea level, again a different fuel mixer. So this is what the Farex are doing. The engines automatic function. We have the overhead panel here now. Also very quickly the APU. So this is electrical. We're gonna start the APU like this. We're gonna run on. We have the battery, APU generator, the contactors, 120, 200 volts, 400 Hz frequency of the IDG, the left and the right engine contactors, external power. We have the primary flight control computers here in the auto position, as you can see. Air data computer, heading reference, IRS, flight control computers, some other functions, timing, FT door, window heat, passenger oxygen here, window heat, rammer turbine. We have here the hydraulics for the left and the right engine. We turn off, you will see what happens, the demand, the primary, which are the engine driven pumps. We have the electric also driving. So we turn back on, you see displays of fault, then to auto like this. We have also the wing and engine guys here. As you can see, we can turn to on or auto right now as we need, as requested. We have the lightings of the aircraft and the windshield wipers. So we have also here, as you can see, the cargo and APU fire over here, some other systems, the electronic engine control for the engines, normal and alternate mode for the engine control. We have the auto start also. We can start the engines like this. Later I will show you. We have the fuel jettison. We can dump some fuel in flight if we arm this switch and select the fuel nozzles and how much fuel to remain. We have the left and right wing fuel tank, the center tank. So this is the fuel booster pumps. Also the crossfeed valve we can use to feed either engine with either pump or either tank remaining, the balance also. So this is the fuel booster pumps and the tanks of the aircraft. We turn off. We have the pressurizer section with the air conditioning here. So we have pressurization. In the manual, use the outflow valves for climb descent, and use the automatic function. So I'm gonna show you now the last thing before make the engine start demonstration. We have the display of all the systems you see in the overhead panel. We have the digital format here. We need also to start turn on the lights like this. I'm gonna start the engines, make an engine start demonstration. So you see all the diagrams. We have here the systems. So the hydraulics, the APU is running. You can see the APU, oxygen, liquid cooling, the electric, left and right tensing, IDG generators, contactors, our own APU generator, the load set, the drive of the generator, voltage of the battery, 31 volts, and the average, and also the APU battery. So this is the electric system, hydraulic, where the hydraulic fluid goes, left and right engine, demand and primary, electric C1 and C2, 5000 psi from each left and right and center, and the quantity of the fuel. Also here we have the fuel system, left and right wing fuel tank, center tank. You can see the minimum fuel temperature below which the fuel will freeze in flight, so you need to heat the fuel and the fuel temperature right now. So the fuel is heated by recirculating into the engine. We have also low high pressure fuel valves, open feed both engines left and right, using the center or the wing, 11,000, 11,000, 11,000, so total 33,700. The APU is fed from the left wing using this motor. Also the corpse feed valve is off, but if we turn it on, it can feed either engine with other tank or either pump. If you have failure, the temperature of the cabin and the cockpit, and the oxygen and the cabin pressurization. The doors are closed, the cabin can be pressurized, landing gear, temperature of the brakes and pressure of the tires, flight controls here. You can see all the flight controls movement. If we move around, you can see everything is working, the stabilizer trim. So this is for monitoring. Here the flight controls function is correct, there is no failure. So we have this display, maintenance, circuit breakers here, also digital, and the last thing, checklist and communication, normal menu, what to do if you have before takeoff, after takeoff, descent, approach, landing. So we go back to the navigation display. We need to restart the engines, so I'm gonna turn off both engines right now. As you can see, fuel control to the off position like this. So we have both engines off. You can see some messages. So we have a couple of minutes to restart the engines and go for takeoff more. So restart like this, both engines. Auto start like this. Here this section you see the amber indications, resets. So we have the auto start will come on when we let the fuel. So you see the N2 is increasing here above 20%. We have enough pressurizer right now. So there is pressurizer. We can let the fuel control left and right fuel flow like this. So you'll see the auto start is kicking in, and we're gonna have the engines ready in a couple of seconds almost. So we have the auto start on. You can see 40%. Auto start 51%. Now we're gonna have the systems on. You can see all the indications are coming up, all the engines are functioning, both engines, and all systems it supplies. We're gonna have running now displayed, so both engines running. We can go for takeoff, so we use flaps for takeoff here, 15 degrees, advance the thrust levers, parking brakes off. So we use also the tiller. We take clearance from the air traffic control for takeoff, like this. So we need less thrust. The runway is open for us for takeoff. So we are lying like this. Advance the thrust levers like this, full takeoff power, as you can see, full takeoff. So we align using again the rudder pedals, left rudder. We have 90 knots, 130 V1, we rotate. So we rotate slightly like this, as you can see. Speeds up altitude. We have positive rate of climb. So now you can also fly hands off. We have a good pitch altitude and you're trimmed right. So we keep climbing. You can see the information from the primary flight display. We have in 200 knots. We are 1,900 feet above the ground, 2,000 feet above the ground, 3,700 above this level. The pitch altitude of the aircraft. We can change the pitch altitude like this. 4,000 feet. Keep climbing. So we have also the display. You can see the terrain around you here. The engines also indication. Autopilot flight director system panel. So let's see here. We need to turn also in a couple of minutes. So you see, it would change all the indications. Look further away. You will see again the airspeed. We have the stall speed here, the marking, and you can see the red, green, and yellow indications of the terrain around you. So this is the aircraft, also the Switzerland view. We need to start the turn now. So we're gonna start the turn now to follow the flight plan over here. And we have 15 more minutes left for this flight. Also retract the flaps like this. You don't need so many. We need to increase the airspeed also. We can see also the flight plan in this display here, the other side. So we have about 15 more minutes left for the flight. So this is a nicer view of the cockpit right now. Also the outside. You can see you can fly hands off like this if you need. The aircraft is gonna be stable. So we keep climbing. Also maybe use less flaps now to increase the airspeed to the maximum climb speed. So you're gonna see now we are much closer to the stall speed here, the marking. But also we're gonna increase our airspeed like this. You can see also the indications here. Head up display. So we need to trim the aircraft, also make a turn now over here. So we have a beautiful view here of the aircraft around the Switzerland. Over here we have the Germany in front of us, so we're gonna turn this way, the France. So we need to pitch down a little bit the aircraft. We have too much pitch altitude. And also make the turn now. The pitch down slightly. So we need to increase the airspeed now, and we have 12 more minutes to reach the airport. Go back into the airport. Keep flying. We're gonna be flying through over here the lake. Beautiful views. So we have the France this way, the Italy, the Swiss Alps, the Switzerland. You can see, and the Boeing 787. Very nice view. And also we have the lakes here, as you can see, beautiful lakes. We're gonna be overflying in a couple of seconds. So we need to be aligned with the flight plan right now. So maybe we're gonna start the turn now. We're to the 3,000 feet. We're gonna be overflying the lake like this over here. So we have the lake in front of us, and beautiful views over here. So we're gonna start the turn now. Over here we have the lake in front of us, and we have 10 more minutes to go back to the airport. So you see here, we make the turn back for the airport. We have the Bayern Munich here, the Germany, my homeland, and the France this way. The galactic view again. Beautiful Switzerland, the lakes here, very close view as we flying. So we make the turn here. And we have 9 more minutes to go to the airport. Also use all this thrust here. For the turn. Maybe use some right rudder here, right rudder pedal to make the turn more accurate. And we're gonna have now the chemtrails, as you can see. The vapors, the Germany, the lake behind us. You can see. So the Germany, the Switzerland here, and the France. Beautiful view. So we're going now back for the flight plan, and we have 8 more minutes left to go. We need to align with the flight plan again and use a little bit more thrust to level off, as you can see. So we keep flying manually, and also start the descent, I believe. We have to start descending now, as you can see, back to the airport. So we have a very beautiful view here. can see the aircraft vapors, the Boeing 787 as that aircraft. So we need to descend now. Gonna use idle thrust and speed brakes. Descend more quickly over here to the airport. So keep descending over here. The airspeed also, the display of the air data, we have it, and we have 6 more minutes. We need to align with the flight plan again, cross through these waypoints and approach and landing. So now we're going for approach as we are descending. Can use a little bit more airspeed like this. So we need to pitch down again. We have a little bit more airspeed, and we have 5 more minutes left for approach and landing. As you can see all the air data here, and here we have the autopilot set. Cross 19,000 feet as we are descending. We need to use again the speed brakes and pitch down the aircraft. So now we need to start the turn towards the airport. We have 5 more minutes left. You can see the airport here. So this is the cockpit inside as we are descending. So we have 4 more minutes left for the approach and landing. We need to make the turn now. Use a little bit more left rudder also as we turn to accelerate the input of the turn rate and coordinate the turn. So we need to align with this line here and here in the navigation display with the flight plan as we are approaching for landing. You will see. So we have the runway here in front of us, and we have 3 more minutes left for approach and landing. So we made a good approach right now. Also landing gear, some flaps down. So we have to cross through these clouds here. So you see here to cross through the cloud system. We need to be aligned with the runway, as you can see, for the approach. We're gonna have also the outside view set. for the approach. Some more thrust also needed, and we have 2 more minutes to go for the landing. As you can see, we have full flaps, landing gear down, align now a little bit right rudder, and some side stick. We have side wind now, so we have lateral wind, pitch attitude now, a little bit more thrust. So you can see the indications here from the Lszh localizer, the approach, the terrain below us, idle thrust, and approach for landing, align with the runway also, like this. We're gonna have the flare for landing now, align again, flight controls, we need idle thrust. So is the flare here, flare for touchdown. As you can see, here we are, touchdown, perfect touchdown. Parking brakes, keep aligned, and thrust reverse here, and slowing down. As you can see, align a little bit right rudder, like this. So keep slowing down. We made a very beautiful landing here, as you can see, where we are all located. The aircraft keeps stopping. So you can see we have all the landing gear here. All the wheels are perfectly safe, there is no breakage. Any tire the aircraft is starting up the way it should be. No broken tires or wheels. Landing gear behind, all the strut parts, you can see all the metal parts are perfectly safe. We can fly again the aircraft for one more flight if we need. So we made a very beautiful touchdown. Disarm like this, the thrust reverse. You'll see the thrust reverse, doors closed. So that was Thomas Hatsien, German American pilot flying the Boeing 787-900-95. Thank you very much for watching.